Hey guys, it's Alexander. Today we'll be doing our first part of our two-part series revolving on creating NFT tickets on Flow. What's up everyone? Before we get into the rest of the video, I just want to introduce a super new and exciting grant program which will be giving out $500 to developers like you who use our Flow videos and contracts to create a new and exciting Flow website inspired by them. So you have a good idea on how to use our videos or contracts in your own new website, then make sure to put a proposal below and have the chance of receiving $500. All right, now we talked about the grant program, let's get into the rest of the video. Now this part of the video will be very similar to a lot of the previous videos we've created. We'll be going into sort of the setup for these NFT contracts, implementing the metadata, and a lot of the other standards that come with NFTs on Flow. So if you've already seen this part or know how to have a sort of intermediate experience in creating contracts on Flow, then I'll put a timestamp below so you can skip it. Now let's get into it. So with Flow contracts on, with NFT contracts on Flow, we have to adhere to a number of standards. Now standards are basically so that people across the Flow network can interact with your NFTs in a consistent and common way. For example, if I created my NFTs completely different from someone else, then it'd be super hard to interact with every NFT in a consistent way. So these standards really make sure that everyone can interact, buy, sell, use, view your NFTs in a pretty standard way. So let's get into the setup for the eventual contracts we're going to create. So getting, real question right here is, how do you find these standards? On GitHub, Flow has created a repository of, contracts with these standards. As you can see here, we're on the repository right now. Now we click on contracts. We can see a number of different standards here, including a non-fungible token standard, metadata view standard, and if you go into utility, a fungible token standard. So we're going to start by implementing the non-fungible token standard. We're going to copy and paste all these standards into the playground, and then I'll talk briefly about going sort of in depth into how these standards work. So now we're going to copy and paste in the fungible token standard next. Into the second account there. Go to contracts. Then we're going to copy and paste in the metadata view standard. Perfect. All right, so now let's go a little bit into depth into what these standards are, how they work, and what is even going on, right? Okay, so first we're going to start with our non-fungible token standard. This is the really essential standard for our non-fungible tokens. Like I said, this allows people to use and view and buy and sell your NFTs in a consistent manner. So starting with the non-fungible token standard, it is a interface, like I said, comes with the ability to basically see a total supply of how many NFTs are in existence. This is an event. An event basically occurs when someone interacts with your contract. A event will basically be sent out to everyone that's using the contract. For example, with this is a contract initialized event in which basically when you initialize the contract, everyone that is viewing it can see it. Now going over, we can see a withdrawal event, which basically was when someone can see when someone has withdrawn the NFT, can see when someone has deposited NFT. This is another event. Now moving over into sort of the resource itself. Resources are unique to Flow. They're basically these sort of, I would call them almost like houses. That's the best way that I would think to call these sort of resources that can be moved around from account to account, to storage from storage, to basically interact with your NFTs. So as we see here with our interface iNFT, it comes with a unique identifier that allows you to see every NFT from a unique, have a unique identifier to each NFT, so there's no sort of overlap. This is an ability to see views, to get metadata views. Metadata basically on NFTs are things such as your title, your image, your description, the person who owns the NFT, things of that sort. Now going over into the iNFT, once again, we have this sort of ID, this unique identifier, so nothing really overlaps between any NFTs. Now going into our provider, this just removes the NFT from the resource and moves it to the caller. With, Flow, there's this really, unique thing called storage. Basically, with each account, there's a number of different storages. There's a public storage and a private storage where NFTs can be moved into. A lot of these sort of more basic Flow knowledge, I put videos down below that you can go check out. For this video, we'll be making it sort of more beginner intermediate level. So we're not going to go into so much depth about sort of the resource interface, what are these words? But I'll make sure to put videos below that you can sort of go over, what is a public storage, what is a private storage, and a little bit of a flow 0 to 100, so you can sort of understand more in depth about, what is even a pub fund. But going more into the interface itself, this is sort of a withdrawal function that you can withdraw from the receiver or withdraw from the provider. Going more into the, right now we can see there's a collection public. Like I said, contracts have public and private storage. This is the public NFT storage. Basically, with each NFT, they'll go into your private storage, and then you'll put a basic, a public interface out there that people can interact with your NFT in your private storage. So this is basically an example of that. We have a deposit, we have get IDs, bar NFT, so you can basically check out the NFT, check out its metadata, and things of that sort. Now going into our collection, this is sort of like the overall collection of the NFTs that exist. So with this, you can see things such as like owned NFT. So I would be able to use that ID that I said earlier with this collection and then uniquely find that NFT. You can get IDs, you can see how many NFTs are in the collection already. And you can see, how many owned, basic things of that sort. And then lastly, you can create an empty NFT collection that basically just allows the creator to see, to basically create an empty NFT collection in their own account. So now moving over to our fungible token standard. This is a contract interface, just like the non-fungible token standard. With this, with NFTs, those are non-fungible tokens, which means that like pretty much every token has to have a unique identifier. With fungible tokens, it's a little different. Not every token needs to be unique. With tokens like Bitcoin and Ethereum, those are examples of fungible tokens that can be, given out in a non-unique manner. With this is a example of the interface for a fungible token. You can have a total supply. You can initiate tokens. These are sort of the events that I talked about earlier. Now moving over into our provider. Same thing as NFTs. You have the ability to withdraw. Now moving on to our receiver. Very similar to the NFTs that we just saw. The ability to deposit. Balance is a new one. So basically, how these fungible token standards work is you get a vault. So the standard will give you a vault where you can own these NFTs in your private collection. And this is an example of this right here. You see the total balance of a vault. You get a balance here, and you can basically see how many fungible tokens you have in that vault. And right here is an example: public resource with a vault with a number of the other interfaces that we just talked about. You can withdraw from this vault. You can deposit tokens into this vault. All come with these pre and post. So I'm going to talk a little about these pre and post here. This basically makes sure that, with all of these functions here, it makes sure that you're not violating anything. For example, here with withdrawing, it's making sure that you're not like withdrawing more than your balance. Obviously that wouldn't make sense. And then
Also here with post, it's doing the same type of thing. It's just making sure that your balance is makes sense mathematically, and these sort of just make sure that the function works overall and nothing like really funny is going on. And then same thing, we're creating an empty vault for our fungible tokens. Now moving over into our third contract, here we will change these to OX2 and OX1. We're doing that basically because this OX2 is referring to this contract here, OX1 is referring to this contract here. Before it was done in sort of a file standard. With here, it's a little different. So now moving into our metadata views, we'll have an interface resolver where we'll get the views, resolve the view. We'll have a resolver collection where we'll get IDs from the metadata. Metadata, like I said earlier, is basically the ability to see your title, your image, your description, all that good stuff. And then we see it right here, UID, UUID, external UI, collection ID, collection display, all that type of stuff. Basically, we'll go into this a little bit in more detail later, but we have an ID for the NFT, a unique identifier. Display is sort of, basically, okay, we have it down here, but this is sort of like the core data behind your NFT, an external URL, royalties, all pretty standard stuff. We'll go down and explain it a little bit more down here. And the name, description, a thumbnail for your display. You can get the display. You can put a file in that represents the image of your NFT. You have an edition. Editions. You have a serial for your NFT, which basically is, like I said, that your UUID. Royalty. So basically, these are really popular NFTs. The original creator can get 5% of all sales, and then also all resales as well into the future. So really creates that sort of really great incentive to continue with the project. Media, these are things like images and videos and anything that you would like. A license, so these are things like if you wanted to allow anyone to use your NFTs for anything, that you can create a license onto it. And then NFT collections with these paths and collection paths. Like I said earlier, with Flow, you can have public, private paths, and basically put these collections into whatever you would like. And then this is the NFT collection display. So these are things such as, the socials behind the person or the company that's created NFTs, banner images, square images, just to represent the NFT collection as a whole. Rarity, these are things like, you could have traits on top of your NFT for games, for example. Like an NFT could have a rare helmet or a super rare armor, anything like that. That's basically what comes with these rarities. Same things with trait as well. And you can basically get all these things via these sort of public functions. Obviously, we won't be implementing sort of all of this, but we will be talking a little bit about more of all these things as we get into the rest of the video. All right, now that we got that out of the way, let's dive into actually making the contracts. So before I actually start writing out, I'm going to explain a little bit about how this is going to work. So we're going to go line by line with creating these sort of NFT contracts, and then later with the scripts and transactions, we are going to just sort of do a glance overview and explain how those work. Starting off with these NFT contracts, just to make sure that obviously this video isn't hours and hours long. We're going to be copy and pasting a couple of things, but I know it can be confusing when watching video. You see developers copy pasting stuff. We're going to go line by line and explain those as well. So for some of the more trivial stuff, we're just going to copy and paste that in. For the key parts of this contract, we're going to make sure to go and explain and go line by line writing those out. So we're going to first start off by importing our contracts here, our interfaces, non-fungible token. Okay, that looks good. Importing our initial interfaces with non-fungible token and metadata views. We're going to name this NFT ticket, we're going to name it use space. So To make it a little bit more simple and explain sort of the overall view of it, we're going to call it use-based contracts. This is an example of a use-based contract, as NFT tickets in themselves are use-based contracts, right? I'm giving you an NFT, you use it, and then the NFT as a whole expires. So it's sort of like a one single use NFT, which is why I think we're going to call it a use-based contract for this. Now we're going to go in to our final contract here, and we're just going to copy and paste some of the more trivial stuff here. I'm going to explain it line by line, though, just to make sure it is as easy as possible for y'all. Cool. Okay, so you may be asking, what even is this? First, we're starting off with our importing our interfaces, then we're creating that contract as a whole, calling it use-based, and then we're importing all of these vars, events, and lets. So let's go line by line and explain what these are. So first we have a total supply. That's just the total supply of how many NFTs there are. Then going back to these events, we described these earlier. So if you need a little refresher, make sure to go back to that initial video or initial little video we did before this. And then here we're just, sort of outlining our paths for storage and public and admin. So nothing really too crazy here, just sort of a first couple of contracts or a couple of variables and events that we need to write this out. Then we're going to go into the metadata. Then we're going to go into the metadata here and sort of write out this. Sorry. Just writing out some of these sort of basic NFT metadata variables that we need, such as our thumbnail, expired. Yeah, so right here we're just gonna be sort of writing out similar to what we did here, the variables and the variables that we need for a metadata, including our unique identifier, the name of the NFT, description of the NFT, thumbnail of the NFT, and then this is our big variable we're adding on. It's called expired. This basically tells us if the NFT is expired or not, if it's been used or not, and then we're going to be basically initializing all of the variables here with the creation of the NFT itself. So nothing really too wild as of now. Pretty standard stuff. So for here, I'll explain a little bit while we're doing it. But basically, like I said, once we sort of initialize this NFT, we'll be passing in a number of different variables to sort of populate this data that we sort of initialized in the beginning. While we do have a variable for expired, all of our other variables are going to be constants, which means that we can't really change those. But for our expired, we're going to make sure that that is a variable so that we can change those based on just based on like, we misspelled that. Sorry. Just based on, if we've used the NFT or not. So that is it for our public struct NFT metadata. Now we'll be moving on to our public resource NFT. So we sort of explained this, or sort of glossed over it a little bit in our in the explanation video, but for this, we will be importing our metadata views and metadata views resolver and non-fungible token standards so that our NFT, like I said, can be used across the Flow ecosystem in a consistent manner. For this, we'll also be, bringing in those initial variables, like I said before, creating, just all these variables that we need, such as description, a string. We actually probably just copy and paste this in here. Yeah, that should be easy enough. But yeah, basically just taking all of those constants and variables that we needed before, just copying them over, nothing too bad. But similar to the metadata, we will also be initializing this NFT with a lot of the same variables that we did before with the metadata. Just sort of importing all of these, making sure we can create the NFT when we want to. And then we will just be assigning all of these with the same variables that we imported. But we'll just be removing these little underlines so that those match up. So looks great as of now. One of the things that we're also going to be doing in this that's sort of different from our metadata views is that we're going to be increasing the total supply to +1. Makes relative sense. We're just, we're creating a new NFT, so we want to make sure that we can increase the number of total supply of NFTs in the collection. So now going over, we're going to be implementing this function called getViews. This function is basically so that we can view the NFT's metadata. So, all these variables that we put up here, ID, name, description, thumbnail, expired. If we want to view those, we need to implement a function like getViews, which is what we're doing right now. So for this, we're going to be accessing the metadata views display. And then we're going to be returning basically this metadata view display and the metadata itself in an array that we can process later. After we've done get views, we're going to implement our next function, which will be our resolve view. In this, we're going to be having input of view and then returning any struct at the end. Within this function, we're going to make sure that we can switch the view with a case. So basically, we're taking in this view and then we're processing it based on this sort of enum case switch that you can see right here. Based on what the view is, we're going to process it differently. So within this right now, we're basically saying that if it's a display, we're going to return this metadata views display and then sort of process the necessary lines here. Name. So as you see here, we're just going to be inputting the descriptions, the basic, display, NFT metadata view display that we need. So nothing too bad here. Thumbnail. So as you can see here, I'm putting that there. As you see here, basic NFT metadata display. We're basically saying that if we see that it's a metadata view, we're going to be giving back all of the sort of NFT metadata that we need, such as our name, description, and then a thumbnail. As you can see here, we're using an HTTP file. That's just a basic image on the internet, a basic, URL that we're pointing to. Right here, you can see self.thumbnail. We're just going to be basically just pointing to that, and then should be good off of that. But now we're moving on to our metadata itself. Sort of the more, more expansive metadata. I'll write this out quickly, and then I'll explain it line by line. Expired. Great. So now let's take a look at what we just wrote. So we have our get views here. We're returning this array of NFT metadata. Display and NFT metadata. We now go to our resolve view. For this, we're going to be switching our view, which means that we're basically going to be taking in that input and then outputting based on what that view is. So for our view, if we get a case of metadata display, which means we want to get back the sort of display of our NFT, we'll be giving back the sort of bare bones, which means we'll be inputting or giving back the name, description, and thumbnail of the metadata itself. From there, we will be going over to our next case, which are NFT metadata, which means this is sort of the more expansive metadata, which includes things like the ID, the name, description, thumbnail, and if the NFT itself is expired or not. So that's a little bit more expansive, allows us to get a little bit more data based on the NFT that we would like. So for the next resource, just to make sure that this video doesn't get too long, we may just be taking a look and copying over a couple of things. Let's see. Okay, so we're going to copy over the sort of initial part of this, and then we will explain the sort of more in-depth functions below. So let's copy this over. Awesome. Okay. What's the function? Looks like we're getting an error, so just checking that out quickly. Looking at my notes. Okay, so this error right here is just because of this apostrophe here. Or comma, something. Sorry. Anyways, now moving over to our next sort of big part of this contract, our resource for our collection. So this is the overall collection resource that sort of houses, everything from owned NFTs to the total supply of just basically all the NFTs are packaged into this select collection right here. Right now, we're importing a lot of the interfaces such as non-fungible token provider, receiver, collection public, and resolver collection. Once again, just making sure that this can be accessed by anyone in a consistent manner. For here, we declare a variable called owned NFTs. It's a dictionary in which you can basically insert a unique identifier and then receive a resource of a non-fungible token. Because we're going to be initializing this collection within this contract, we will be making sure that this dictionary itself is empty at the beginning. So now we're going to be moving over and we'll be creating our next function, which is a withdrawal function. This function in itself is going to allow us to basically input that a unique identifier and then withdraw, withdraw a NFT from the collection itself. So we basically create the function, create the input as a unique identifier, and then say we're going to return a non-fungible token. From here, we will basically be creating a withdraw ID So I'm going to write this out really quickly, and then I'll explain it right when we are done. So token ID here. Address. Turning a token. Okay. So let's dive into this function. So we'll be starting off by creating this let token. We'll be diving into this collection that we just, or this resource, or this dictionary that we just created here. We'll be removing a key from a withdrawal ID, and if we can't find that NFT within this dictionary, we'll be declaring a panic, which basically abort the whole function and say that we're missing the NFT within the dictionary. Then we'll be emitting this to the withdrawal, which will basically tell everyone that's looking into the contract that we have withdrawn a NFT. And then we'll be returning this token to the user. So now moving on, we'll be implementing our next function, which will be a deposit function, which we will be depositing the function as depositing the NFT into our collection. So I'll be writing this out very quickly. Token.id. Okay, so for our deposit function here, we will be taking in a resource of a non-fungible token. We will be creating a variable called token, in which we basically access this token as a use-based NFT. We'll then be declaring a unique identifier variable in which we access the token that we just described here, the unique identifier of this token. Within this, we'll basically be going to our dictionary over here and inputting the token into the correct place based off its unique identifier. And then lastly, we'll be emitting a deposit, basically saying, hey, we deposit this into the function. If you're listening, check it out. Next, we'll be creating our variable for get IDs. For this, pretty simple, just going to be getting the IDs of the sort of function, of the collection. For this, I think we will just be copying this over. I know we're getting up to 20 minutes, just to make sure that y'all aren't sitting here for that long. We'll just be copying over a little bit of these basic last functions and then explaining them as so. So for these last functions, they're really nothing too crazy. First, we'll be borrowing the NFT. So if we want to borrow the NFT from the collection, we'll be using this function. We'll basically be inputting a unique identifier of an NFT and saying that we're going to be returning an NFT. For this, we'll be accessing this dictionary, and by inputting the ID and returning it as a non-fungible token.nft. Next, we're going over to our borrow view resolver. For this, we'll be inputting a unique identifier and then looking to return a metadata view resolver. I see here we have an NFT. We're equaling it to the self.owned NFTs, accessing that dictionary once again, and looking to get the non-fungible token.nft. For this, if anything really goes wrong, because we're using exclamations, the whole entire function will basically cancel out if anything goes wrong. Just making sure that, if we try to access an NFT within our collection that isn't there, the function doesn't go through. So once again, we'll basically create a variable here called use-based. accessing the NFT as a use-based NFT, and then returning it to the user as a metadata views resolver. And then our last function here is a destroy function. This is basically so that user, if they want to, can destroy all of their owned NFTs in their collection. So pretty standard functions right there. We'll be moving over to our next function, which will be basically to create an empty collection. This we will be non-fungible token collection. We're doing here, return a create collection. So as you see here, it looks like we have a list got identifier. Sorry, looks like we're gonna go back very quickly. Looks like we have an error in our resolve view. So let me check this out very quickly. Collection, description. I see the error. Empty metadata. And then, yeah, perfect. I think. Let's just return this. That should get us the NFT metadata. Got the illuminator. Okay. That should be good now. The error should eventually go away. But yeah, you know, like this is coding. Errors occur. You just have to, you know, roll with the punches. Now moving on. Great. Now that we created the empty NFT collection, we'll be moving over to our public resource of our admin. This is a super important resource right here. So I'm going to be explaining this line by line. Before we go into this resource, I'm just going to sort of try to explain what it even is. So as we're creating these NFTs, we need sort of a admin that's going to be allowed to mint the NFTs and expire the NFTs themselves, which is what we're sort of doing here. You know, we have an admin so that like not everyone can access this contract and then mint NFTs and expire NFTs by themselves. We're sort of creating a central admin that has control over this, so that not everyone can just mint NFTs whenever they want. But that is what we will be doing here. We will be basically inputting a collection, a non-fungible token provider, and then inputting our collection public into this function. And a number of different other inputs that we need. So let me quickly write this out. String, thumbnail, string, expired, bool. So right now we're also creating the ability to basically create a new NFT within this function. Thumbnail, and then expired. Expired. recipient dot deposit. Okay. Let me try to explain this now. New NFT. Awesome. Okay. So right now we are creating the function for our emit NFT. Boom. Perfect. So we're basically inputting a recipient collection. So this is basically saying, hey, I want to mint an NFT. Who do I want to mint it to? This is the recipient that we're inputting. This comes with their collection public. So we're basically going to this recipient. We're saying, hey, where do you want us? We want to give you this NFT. Where do we want to put it? That's where we're going to put it in this collection public. And then we're sort of writing out the other sort of identifiers for this NFT. So like, for example, we want to mint this NFT, but like, what do we want to be in that NFT? That's what we sort of saying here. ID, name, description, thumbnail, expired. Basically just writing out exactly what we want to be said in that NFT. Then we're creating a variable for a new NFT where we create this NFT with all these necessary sort of metadata, and we put into this variable resource called var new NFT. And then lastly, we're giving the recipient this NFT by depositing it into their collection public here. So that was our mint NFT function. Now we're moving over to our expire NFT function. This is basically our central function for this like whole entire project, really. So we're going to be inputting a number of these different inputs. Then we will be basically creating a variable here and calling it old NFT. So we're going to say, hey, we have this unique identifier that we're trying to find, or this NFT with this unique identifier. We're going to destroy it. And then we're going to create a new NFT, like so. And we're going to input it with all the necessary variables. Basically just going to destroy the whole entire NFT. So let me write it out quickly. Expired, true. And deposit. Okay, so let's look at this expire NFT function. So similar to how we minted the NFT, we'll be taking in a NFT collection public and a provider, and then a unique identifier for the NFT itself. We'll be creating a function in which we basically say, hey, we're going to take your old NFT, which you would do right here, where we withdraw the function itself by the unique identifier, we put it into this variable, so we move it over, and then we destroy the NFT itself. And then we're creating a new variable where we say, hey, we took your NFT, now we're going to give you back sort of like a receipt almost, where we create a new NFT and we put in its ID, but we make all these NFT description thumbnail just empty, and then we put the expired as true. So we're saying, hey, we're taking your NFT, we destroy it, and then we're depositing this new sort of receipt NFT back into their function, or back into their collection, which we say, hey, here's your ID that we just destroyed and that it's expired. Sorry. And now that sort of concludes most of our function. We're moving over into self.total supply, or some of the initializers that we need for the contract itself. These are pretty basic, so we actually might just, we'll write these out quickly. Storage path, storage slash use-based collection. So as we've been talking about, sort of throughout this whole video, we, with Flow, Flow is very unique in itself, as many different other competitors like Ethereum or Solana or anything else. They basically allow you to deposit and destroy and mint NFTs onto one central account. Flow has made it so that they're hyper secure, basically, by implementing these sort of different accounts, which allow you to basically ensure that your NFTs will almost never be taken away from you or hacked or anything like that. They do this through this unique sort of NFT selection. So finishing out with our init, we're basically saying here, once we create this contract, the collection as a whole has a total supply of 0 NFTs. As obviously no NFTs have been minted yet. Then we're basically saying that for this collection, if you want to access it, these are the sort of accounts that you should look at. So for a storage path, it's just storage/use-based collection. For a public path, it's public/use-based collection. And then for admin, it's going to be storage/NFT admin. So later you'll see our scripts and transactions, and this is where these sort of paths come really into play. By having it within the contract, we can access the contract and find where those consistent paths are. Also, in the initialization of the contract, we'll be creating an admin and then saving that admin into that storage path that we just described. And then lastly, we're going to emit this function that we created the contract and initialized it. So that pretty much ends it for the whole entire sort of walkthrough of the use-based contracts, also known as the NFT tickets. I'm back. Just made a quick little copy and paste of our final contract. Has a small little error, but nothing really too crazy. Now we're just going to move on to our transactions quickly here. Moving on to our transactions. These can look a little complicated, but really nothing too crazy here. I know we're getting up there in time, so I'm going to quickly go through these to make sure you guys have the ability to move on to the next video. Don't just sit here watching me creating these contracts and scripts. Yeah, quickly create these use-based contracts for OXO1, OXO3. Okay. So that does it for our transactions. Let's take a look at what's going on in these transactions specifically. So first, we are inputting an ID, a name, description, thumbnail. Very simple. For this is our minting contract. So we will basically be accessing the collection here, accessing the admin path as well, and then we're going to be preparing and basically borrowing the admin resource from our path, getting the account itself, and then basically inputting an empty collection into our admin path. We're then going to link it to the other collection paths that we saw before. Then just finding the get capabilities. So we're basically, once again, just borrowing the recipient collection. And now at the end, as we've done this in the sort of prepare section, since we're creating the empty collection, we're then going to mint the NFT to the collection with the inputs that we had here. And then log at the end, minted, basically saying, hey, we minted the NFT. Now going into our next transaction, we have a owner collection. So we'll be basically creating a collection for this, saying this is our, let me make sure, this is our update. Okay, so this is our update transaction. So we're basically taking an NFT, we're accessing it from the owner collection and borrowing it from the admin. And then at the end here, we're going to be expiring the NFT by calling the function itself and saying, hey, this is our collection, this is our ID. And after that, within the NFT, within the contract, it will expire itself. And then we're going to log at the end that it is expired. So let's move on to our scripts. This is very simple, nothing too crazy here. We're just going to get our NFTs. My little bubble's in the way. Anyways. Okay. 4, 603. Awesome. So here, we're basically just going to get the account and then say, you know, if you don't have a reference, then we're just going to panic. We're then going to get all the IDs. We're going to go through each of the IDs and get all the metadata and append it to the display. And then lastly, we're just going to return it to the user through this script. So that pretty much ends our walkthrough of the contract itself, the transactions, and the script. Next, we'll be moving over into basically implementing these contracts into a simple website and really wrapping together this whole entire project. So that concludes it for our first part. Thank you very much for watching, and make sure to come to our next part and see how we implement these into a new and exciting website.